Today's talk is based on a talk that I just recorded for ADS, and that is not launched. I think it's coming out in November or whatever. And I was given 7.5 minutes. So what I would say about the two talks is this is probably the more interesting one because I have a little bit more time to talk about some of the details. So 20 minutes is quick, but it could be a lot quicker. I want to thank the organizers for also allowing me to do this. I didn't know I was going to be in London until last week. I'm like, I know it's 2 months late, but could I give a talk at DroidCon? So here I am. I want to talk about some of the interesting stuff in graphics. I joined the graphics engineering team last year because I like graphics. And what I like in particular is that we have started to add functionality. If you think about the graphics APIs that we have and the history of Android, something that for some reason has been on my mind for the last few years, we acquired a company called Skia in 2005. They had a native rendering engine, and they had native APIs for those. And the first thing they did was to wrap those native APIs with JNI and create classes like Canvas and Paint and Drawable and other related classes. Path is in there. And then the next thing they did for our APIs was nothing. That's basically the last time that we really took an active stance on the graphics APIs in Android because we had other problems to solve. And it's a 2D rendering engine. You know, it's not like, it's A, not rocket science. B, it's not like we're inventing new ways of doing 2D. However, there are new things that we could be doing and new capabilities that apps need, and we have started to address some of these. I'll talk a little bit about this at the end. It'd be nice to keep addressing them, but there are some pretty interesting features that have come out recently. So let's talk about those. The first one is blurs. So for many years, we kind of purposely made it hard to do blurring on Android. And I say purposely because it's a really expensive operation, and we don't like to allow our developers to paint yourselves into corners with our APIs. So if we give you a really cool thing and it performs horribly on half of the devices out there, then we're really not doing great things for the overall ecosystem. So we had something initially, I think in 1.0, dim window. When you pop something to the foreground, you can say, I want to dim everything behind it. That was originally a dim plus blur, and they disabled the blur because of this reason. And I remember having conversations with the graphics and UI team over the years, like, hey, could we do the blur thing? I'm like, no, bad idea, because then things are going to be really horrible. However, we finally got hardware and capabilities and approaches that made this reasonable, so we may now make it easier for you to actually dim behind stuff and get the effect that you're looking at. But before I want to talk about blurs, I'm going to talk about a render effect, which means I'd like to talk a little bit about how drawing happens on Android. So you can think of everything in applications, like certainly everything in the UI is a series of commands, of really low-level drawing commands saying, draw this line, draw this gradient, fill this thing, copy this bitmap. All drawing commands are essentially this. There's sort of three operations, three things happening in all of the Canvas commands, at least. First of all, you have the operation itself. This is what I want you to do. This is where I want you to do it and how large that thing will be. And these are the attributes that are going to be assigned to it. This is how I'm going to draw this object. So in Paint, we have a couple of categories of attributes there. First, there's some simple ones like, I want you to draw in the following color, or I want the line to be, or the outline to be the following width, or I want this to be a filled object versus an outlined object, or maybe both. And then there's some more interesting and complex ones. I'll group these together and say, well, we have the color filter thing, including my favorite API, color matrix color filter, just because it seemed really important to repeat words in there, I think. And shader. And this one gets really confusing because I'm going to talk about shaders later. And the previous talk also introduced AGSL shaders. And they're related, but it's easy to get them confused in terms of capabilities. Anyway, the original shader API basically gave you access to things like gradients and bitmaps, so that when I draw this line, when I fill this rectangle, I'm going to sample those color values from a bitmap over there, or a linear gradient, or a radial gradient. So now we get to render effect, which is this new API that was introduced a couple of releases ago that enables this blur thing. So we could all do all that stuff with Paint before, but the idea with render effect is we can bundle this up and do it all in a view for you, as opposed to all of the attributes that I talked about before. That's for custom drawing. So if you want to fill with this kind of bitmap, you'd basically have a custom view, and then you would change the attributes on that Paint object, and you would draw into Canvas doing this operation. but maybe you just want a gradient applied or a particular shader applied to an overall view for everything that it's doing. And that's why we came up with render effect. It's kind of a way to bundle up the attribute and just assign it to a view so that all rendering does this, so you don't have to actually do a custom view and do everything so very manually. The API is simple. You just say set render effect on the view, and it's one of these collection of render effects that you can create. But there are a handful of these things that we allow you to create automatically. So there's, again, something for bitmaps, render effects, and the color filters I was talking about before, blending, so you can composite things and say, what are they going to look like when they're composited together? And this new blur effect. So let's take a look at this simple and stupid application that I wrote so that I could play with all of this stuff. So if you look at this video, I have the seek bar up at the top, and you can change the radius of the blur. The radius of the blur essentially gives you the quality or the amount of information that is going into each of the blurred pixels. It's kind of an expanding radius of information. For this pixel, I'm going to look at all of the pixels surrounding me. And the larger that radius is, the better quality or the blurrier the image is, because you're just taking in more and more information to create it. Now, in terms of capabilities, I would never want you to write an application that gives the user a seek bar to change the radius of the blur, because why? But for me, I kind of wanted to play with the effect and see what was going on. The intent of this was to actually create a UI effect that I'll get into a little bit later, though, because I wanted to blur behind some other content. But I at least wanted to know how the blur was going to look and how it was going to interact and what the APIs are that I needed to play with. So as I get the events coming in from the seek bar, I have this little progress change callback there, and then I call this update effect method, which is implemented down here. And the first thing I do is say, okay, so if the progress is greater than 0, then I'm going to set the radius according to what that progress is. So basically just take the seek bar value and pass it in. When I create the render effect, I'm going to say blur is going to have the following radius that was passed in. I should stop here and say there is what I would call a bug. I think some people on the team might say, no, this is what we intended. But if you pass in 0 for a blur effect, you will get a, what's the word? Crash. You will crash, right? So effectively, like, it's kind of dumb to pass in 0. This is a response I got from some people on the team. I'm like, hey, when I pass in 0, my app crashes. Well, you shouldn't pass in 0, because that's basically saying, give me a blur that's not a blur. And why would anybody do that? I don't know, because it seemed reasonable to pass in a random value, but apparently. So just so you know, if you don't want your app to crash, don't pass in 0, which is why there's this little condition in my code. It says, if they passed in 0, just don't set a blur, because that's a bad thing to do. But just so you know, we do know about this. There is a bug filed, but it's not fixed yet. All right, so now we have the blur effect, and now we set the render effect, which is the API I mentioned before. So we basically said blur everything going into this view and set the render effect on this view, go. All right, so now we know how to blur behind. So let's talk about actually doing something interesting on top of that. So there is this new API that was introduced in the previous session here. It talks about shaders and shading languages in Android. This is the latest, greatest API that came out in the last release. Gives you ability to have pixel shaders in Android, finally. And pixel shaders, it's kind of like a really, really big, flexible hammer that will do anything you want. Because you are changing, using programmatic logic, you're changing everything happening in a particular pixel in an object. Now, I should point out there are some graphics people in the audience who are going, he shouldn't be saying pixel shader, because it's actually called a fragment shader. And that's true. I think that is the more correct name. Fragment refers to the pixels that are actually going to be displayed, as opposed to all of the picture elements in a display. It's a bit of a nuance that I think nobody in this room should care about, except those people who think that I'm saying the wrong word. They were originally called pixel shaders. I think everybody knows what a pixel is. Only the graphics people know what a fragment is. So I'm going to call them pixel shaders. But you can call them fragment shaders if you'd like. All right, so what is a pixel shader? It's basically a little snippet of code that runs on every single pixel on a display. Which seems weird. Like, when you think about it, you're thinking, wow, that's a lot of overhead. I'm an Android developer. I try to do as little as possible because the Android team always told me I should. And true. However, the weird thing is, Pixel shaders are already running on every single pixel on the display. It is how GPUs work. You tell them how to set the color of a pixel, not by saying, here's a color, but you basically pass it a little bit of snippet of code for it to determine what that color is. Ever since we've been doing hardware acceleration in the Honeycomb release, this is how we do it. We create shaders internally. What we're doing with AGSL is we are allowing you to create your own shaders and then integrate those with the rest of the shaders so that we'll have this one monolithic shader, this one monolithic piece of code that runs for every pixel in your application. So don't do anything like really long and complicated, because yes, you are going to be doing that on every pixel. However, it is kind of the way things work in the graphics world, in the 2D graphics world in particular. So I have a visual that I created. So there's this site called shaders.skia.org where you can see a bunch of shaders, some examples of how to do this stuff, and you can even basically delete the code in one of those and write your own and then debug it. It's kind of a nice little playground where you can mess around with shaders. So here's a simple shader that creates an interesting visual. What I really liked about it was the code was small enough that I could put it on the screen and display this concept. So basically, that is running on every single pixel on the display, and then eventually you get an interesting visual like this. And on the site, you'll see it's actually animated. So not only can you run the shader, all the stuff that I'm going to be doing today is all just static. But you can animate these values and just keep updating the variables for the shader, and then this thing will move around and do interesting things. So here is the site that you can play with, shaders.skia.org. So this is me poking around and clicking on some of the demos, and you can see they're doing like really visually fascinating things in not a lot of code, except it's not a lot of code multiplied times number of pixels on the screen. Animating values, using the location within the display to determine what I should do here with all these random, interesting, cool effects. I think the next one is, I don't know. Anyway, one of those was the code that I showed earlier, that sort of spinning sphere. So really interesting, but all very custom graphics. Like, I think this is what people think of when they're thinking shaders, like, I can do anything. True. But what interests me in particular is what can we do for UIs? How can we use the capabilities and the power of things like shaders to enable better UI experiences, to make things richer for users of your application, as opposed to users who want to see really random and amazing graphics on the screen, but I'm not quite sure how that helped me fill out the form that I wanted to. There is also this playground, like if you actually enter your own shader code, then you can debug it. You get basically a callback with a sample pixel value. You can step through and see what's going on, which is really nice, because if you try to do that on Android, like there is not a debugger for AGSL, so you kind of write some code and you pass in a string. Like, it's taken us all the way back. Like, we're not doing punch cards, but we're getting pretty close. You pass in a string, the string gets compiled into bits that run on a GPU, and that's the last you get to play with it. You don't get even print line, right? Like, I'm used to print line debugging. No, we don't even give you print line, because it's so far embedded in the system that you cannot get that information back. So tools like this, and I think Shader Toy does the same for GLSL shaders, it's kind of nice to be able to play with the code somewhere. If something's going wrong, you kind of want to know what's happening when your code runs. All right, so let's talk about AGSL. In Android 13, it stands for Android Graphics Shading Language. It is basically SKSL, which is the Skia shading language, which is basically the GLSL. It's very similar syntax. All of these things based around the same thing. The reason that Skia is a little bit different is that it is not. So in GLSL, you are setting the value of those pixels. In SKSL, you are setting a shader that goes in to work with all of the rest of the shaders that are doing things like figuring out clipping, like figuring out anti-aliasing, and so they all get combined into the shader that actually runs on each fragment. Similarly, AGSL is the same thing. We just kind of arbitrarily renamed it because it seemed weird to, in the middle of the API surface for Android, to have something called Skia. I thought that was like a little bit of detail that not everybody needed to know from the outside. Let's see. So you basically create a runtime shader. As I said, you pass in a string because that seemed like a good idea to somebody. And then you set a shader on the paint. You're going to manually draw this thing. You're going to tell the paint what to use. This is the attribute that you're using. So at this point, I should say how this interacts with the existing shaders. So in 1.0, we had APIs called shaders, and now we have something else called shaders. And to some extent, they're completely different, but to some extent, they are doing the same thing, right? Both of these are a way to manipulate or to sample the value, to determine the color value for each pixel. But the new thing about AGSL shaders is you do it programmatically, right? You have that logic in your code. The other shaders that we have for bitmap effects and gradients, basically you pass in parameters to say what you want to do, but then it's static. The logic that it has cannot be modified, as opposed to the logic in AGSL is completely modifiable. So it's confusing that they're both called shaders. They are kind of the same thing, but AGSL is full-on programmatic logic in addition to everything else. And then you create this runtime shader effect using the new render effect API, and then you set it on a view if you want. So again, you don't need to manually create a custom view and draw into Paint. Instead, you can set it on a render effect, and then it happens to run on everything happening inside of that view. Visually, the process looks something like this. So you have this input color coming in. Otherwise, if you didn't have this shader in the way, this is the color that would be displayed. We send it through the shader logic, and then it comes out the other side as an output color that gets returned. So if we look at what's going on in this very, very simple shader that I wrote, you have information about what the XY location is for the pixel that you are drawing right now. It's kind of nice to know where that is in the image in case you have any location-specific logic you want to run. Here, I'm creating a color, just a static color red, and then I'm mixing that. I'm doing interpolation between red and the input color that was coming for this XY location, and then the result is going to be a red-tinted version of what came in. So this is essentially what you get in. You have that image that was going to be drawn, and then we run our shader on it. We tint it halfway between the input color and the red color, and then you get that much worse version of the image out the other side. Okay, so the whole reason for doing shaders, in addition to talking about blur before, as I said, was to think about what we could do for UIs to make them easier to use. So I wanted to combine the blur effect that we have with a frosted effect for the final result. So for one thing, the whole reason to have a blur in UIs is to help focus the user on things that they should be looking at instead. If you think about this in other domains like photography, it's how we use depth of field. You focus on this subject because there's a lot of things happening in this picture, but I really wanted you to look at this face, at these eyes, and it helps draw the user's attention. This is also a technique I've seen in cartoon animation where they will do things in the animation to make sure that you are looking at the point of action and not getting messed up and confused by everything else going on in the scene. They'll have the main character rear back before they perform their action, and that draws your attention so that you can then follow the action in the scene. There's a lot that's done to draw users' attention to things because we're humans and we have easy failure modes and short attention spans, and anything that visual designers can do to help us understand what we're supposed to extract from any scene is very helpful. And so blurs can be helpful for, say, blurring behind so that you understand that you're supposed to be looking at the thing in the foreground. And in particular, what I wanted was this concept of you have an image gallery and then someone wants to focus on a particular image. So when they click on it, then we're going to blur the stuff behind it and pop that image up. But then in addition to that, in the image itself, we're going to use another blur effect in addition to a frosted effect. And all of this is going to happen in a shader to help you understand what the text is in the caption. So the caption is overriding the bottom portion of the image. And if we just had a transparent text view there, you probably wouldn't be able to read the text a lot. So I wanted to draw something behind it to make it a little bit easier and help the text pop out. And then see how we would use both blurs as well as shaders for doing that. All right, so what is going on in this application is we have a container that's holding all the images. This is just a view group where I have a bunch of image views in there. Then I have the image view that we pop out with the actual image content. And this is where we run the shader that has the logic to determine that additional blur as well as the frosted glass effect. And then we have the text view that is simply drawing the text on top. So the shader is created by creating the runtime shader effect, as I said before. Plus, we're going to change a couple of variables in there, variables called uniforms. So we say set the value of the width and the height, and this gives it information about how large the label is, because that's the area in which we're going to run our shader at the bottom of the image view. And then we're going to create the runtime shader effect and pass in the name input shader, which is the uniform or the variable that's going to hold the input input color. And that's information that the shader needs to know. And then we're going to set the render effect on the view itself. This is I think this is an override inside the image view that I was talking about before. All right, so this is the shader itself. This is the wonderful string that I created with all of this logic. This is on a couple of different slides here. So we have the uniforms that I talked about before, input shader, and the width and the height for determining the label area. We are given the coordinates of the XY location that we're looking at right now. So we're going to say, okay, what was the current value that's coming in? And then we're going to look at where this thing is. And if it is below the label area, then we're just going to return the value that came in, because I only want to shade and run a blur on the stuff inside that label area. So that's a no-op. Otherwise, we get into the logic of the shader itself. So first of all, there's a little bit of conditional logic out there. It turns out if you do a blur on the edges of things, things get a little bit funky, because then they're looking at values outside the area you're looking at, and I didn't want to deal with that. So I just said, okay, make sure we're inside the area. And then we're going to do a couple of things. First is that we're going to do a simple box blur effect, which goes out and samples all the pixels to some radius around where we're at and just averages them. Simple average. It's not as good a quality as we get with the system blur, and also it ends up taking a little bit longer, but I just wanted some sort of simple blur here running under my frosted glass effect. So we're going to get the value coming in, and we're going to sample it at all the pixels in that 5x5 radius around here and average them up to get our box blur. And then we do the frost itself. So the frost is a simple gradient. I should point out, again, for the graphics people in the audience who are going, well, you could just use a gradient. You didn't actually need to use AJSL. But correct. That's correct. This is a little bit too much effort just to get a gradient frosted effect here, but I wanted something simple enough to explain. I would say don't use shaders unless you actually have a reason to, but do understand how they work, which was more the point of this. Anyway, the frosted effect is essentially a translucent white, where we're going to go from opaque white in the upper left of the label area down to mostly transparent over in the lower right. And so it has this sort of changing effect that's going to go from white down to mostly the input image there. And then we're going to have the text overriding that. We use this built-in function called mix, which is going to do a linear interpolation between these two values. And that is it. OK, so that's the whole shader thing. And that is as far as I took it in the ADS talk. But now we can talk a little bit more. How much time do I have? Not much. I'm going to run really, really quickly. All right. So what if we wanted to use the system effect for doing better blurs faster? We could do that, and then we end up with something like this, which is not really what we wanted. We didn't want to blur everything, because render effect operates on the entire image. So we can't do that. So what if we use the text view instead? What if I actually just shaded the text view, because that's where I want the effect? But that doesn't work because, so this is what you get there, because it's going to blur the text itself. Also, it doesn't have the background pixels. Text view is transparent. We're blurring the contents in the view, not what is behind the current view. So that doesn't work. See how fast I'm going? I'm going to end, really. All right. And yeah, and then you don't get any blur at all, which is also not what we wanted there. All right, well, what if we wanted an intermediate view? This basically has the same problem as the text view. Like, we do not have the image pixels in the content area, and so we're not blurring anything. So that doesn't work. So the result is use two render nodes. Render node is a way to cache the information that is happening for any particular view. It's what we used internally, and it's a new API that we exposed a few releases ago. You create a render node, you get a recording canvas, you do your drawing operations, and then it's basically this data structure that holds those rendering operations. You can use this technique to do exactly what I wanted, which is basically you have one render node holding the image stuff, you have another render node holding the blurred version of the render stuff, you draw it to a different space in there, and then on top of that you run a simplified shader that is not doing a box blur, it's only doing the frosted effect, and then you have a text view running on top. I think I walked through the code there, but I think they're yelling at me. So I think I'll just say, yes, it worked. If you want the details of this, I am mostly finished with some Medium articles that explain all of the stuff that will come out when the ADS talk comes out. So about November. So you can look for me on Medium if you want the actual code and a little slower explanation of how all this stuff worked. If you have a render node that you're using that you're going to redraw that content many times, I would suggest you use a compositing layer. It allocates a little bit more memory and essentially stores a bitmap or ends up being a texture, and then it's going to be a lot faster operation to redraw that. We'll skip the takeaways since that's just a summary. I did want to say, as I said earlier, I want to help improve our graphics APIs. It's why I joined the graphics engineering team. I believe some of our APIs are unnecessarily difficult or maybe just a little bit dated, and I want to see what we can do there. If you use our graphics APIs, if you're doing Android graphics right now, any kind of custom stuff, and you think they're especially difficult and you have opinions, contact me. I'm going to regret this. I just opened up my DMs on Twitter, so you can send me a message there. And when something horrible happens, I'm going to disable that. But just get a hold of me or talk to me at the conference. I'd like to talk to you about what you think we should be working on. And that's it. Thank you. Sorry, one more thing. Greg went out of his way to get books. There will be books available, and they will be available probably after my Q&A session, which is at 1:10. So come to the Q&A session, bring a good question and ask it, because that's probably how we're going to determine how the books get distributed. So please come, please ask questions. Talk to you later. Thanks.